Welcome, cosmic explorers. Today we're embarking on a journey straight into the blazing heart of our solar system, the Sun. The Sun isn't just a bright spot in our sky, it's the gravitational anchor, the light bringer, and the heavyweight champion of our cosmic block. Prepare for a blend of science, subtle humor, and jaw-dropping facts that might just make you appreciate your next sunny day from a safe distance. Let's dive in and meet the star of the show, quite literally. And if the solar system were a family dinner, the Sun would be the one who claims all the mashed potatoes, piling its plate high before anyone else even gets a chance to reach for the serving spoon. It's the guest who sits at the head of the table radiating warmth and attention, and everyone else just has to work around it. And just when you think it's had enough, the Sun still asks for seconds, making sure there's barely anything left for the rest of the family. That's how dominant it is in our cosmic household. Our star is so massive that over 1 million Earths could fit inside it. Imagine lining up Earth after Earth, packing them in tightly, and still having room to spare. The Sun's sheer volume is almost impossible to comprehend. It's like trying to fit every person on Earth into a single room, and then realizing you could do it 1 million times over. Its diameter? A staggering 1.4 million kilometers, enough to line up 109 Earths end to end across its face. That's like stretching a line of Earths from one side of the Sun to the other and still having a bit of space left over. The Sun's immense mass pulls itself into a perfect sphere, and its powerful gravity keeps the planets, comets, and asteroids in check, making sure everyone stays in their proper place. Without the Sun's gravitational grip, the solar system would fall apart, with planets drifting off into the cold darkness of space. It's the glue holding our solar system together, a celestial giant at the center of a cosmic dance, orchestrating the movements of every planet, moon, and asteroid with its invisible force. So next time you feel small, remember, the Sun makes everyone else look like the side salad at the dinner table. No matter how big you think you are, next to the Sun, we're all just tiny appetizers in the grand feast of the cosmos. The Sun contains a staggering 99.86% of all the mass in our solar system. All the planets, moons, asteroids, and comets combined are barely a rounding error compared to the Sun's bulk. Jupiter, the largest planet, is like an ant flexing at an elephant. This mass gives the Sun its gravitational pull, dictating the orbits of every object nearby. It's this mass that allows the Sun to perform its most vital function, nuclear fusion. The Sun is the undisputed heavyweight champion of our cosmic neighborhood. At the heart of the Sun, nuclear fusion fuses hydrogen atoms into helium, releasing enormous energy. Under extreme pressure and temperature, hydrogen nuclei slam together, creating helium and unleashing photons. This process happens in the Sun's core, where temperatures soar to about 15 million degrees Celsius. Every second, the Sun converts about 600 million tons of hydrogen into helium. The energy released keeps the Sun shining and powers life on Earth. It's been running smoothly for 4.6 billion years and has plenty of fuel left. So next time you bask in sunlight, remember, you're soaking up the byproduct of a stellar nuclear dance. Let's talk about photons, the tiny energetic packets of light that make sunshine possible and bring warmth and life to our planet every single day. These minuscule particles are the reason we see the world in color, the reason plants grow, and the reason we feel the Sun's gentle touch on our skin. But did you know that a photon's journey is nothing short of extraordinary? Their adventure begins deep within the Sun's core, where nuclear fusion creates them. From there, their trek to the surface can take thousands or even hundreds of thousands of years as they struggle to escape the Sun's dense interior. Inside the Sun, photons are constantly bounced around, absorbed and re-emitted by countless particles in the Sun's incredibly dense layers. It's like a cosmic pinball game, with each photon ricocheting in unpredictable directions, sometimes traveling only a few millimeters before being absorbed and sent off again. By the time a photon finally bursts out of the sun's surface, it's taken a path so wildly zigzagged and tangled, it would make even the most advanced GPS system give up in frustration. The journey is chaotic, full of twists and turns, and no two photons take exactly the same route. But once a photon finally escapes into open space, its journey speeds up dramatically. Now, nothing stands in its way. Photons zoom toward Earth at the incredible speed of light, about 300,000 kilometers per second, making the final leg of their trip in just over 8 minutes, crossing the vast emptiness between the sun and our planet. So, the next time you step into sunlight and feel its warmth on your face, take a moment to appreciate the epic odyssey each photon has endured. From the heart of a star to your skin, every ray of sunshine is a traveler with a story. They're the ultimate late arrivals, having spent eons in the making, but when they finally reach us, they light up our world and make every moment in the sun absolutely worth the wait. Let's take a daring step up to the sun's surface, well, as close as we can possibly get without instantly turning into cosmic toast. Imagine standing on the edge of a gigantic ball of fire, feeling the unimaginable heat radiating from every direction. The sun is not just a bright spot in our sky, it's a raging inferno, a powerhouse of energy that fuels life on Earth. Here, at the sun's surface, temperatures soar to about 5,500 degrees Celsius. That's over 9,900 degrees Fahrenheit. It's so hot that even the toughest metals would melt in an instant, vaporizing before your eyes. This is a place where nothing solid can survive, and the very air would be stripped away by the intense energy. The sun's surface, known as the photosphere, isn't solid at all. It's actually a layer of superheated gas, an ocean of plasma that's constantly roiling and bubbling with energy. Massive solar flares and eruptions shoot out from this layer, sending waves of charged particles hurtling through space. The solar surface is in perpetual motion, with convection cells creating a mesmerizing, churning, boiling effect. These cells are like gigantic bubbles, each one larger than entire continents on Earth, rising and falling as heat moves through the sun's outer layers. Even our most advanced spacecraft have to keep a respectful distance. The Parker Solar Probe, humanity's boldest attempt to touch the sun, can only get so close before risking a catastrophic meltdown. Its heat shield is pushed to the absolute limit, protecting delicate instruments from the sun's relentless fury. So, next time you feel the sun's warmth on your skin, remember you're enjoying it from a safe 93 million miles away. That distance is just right, close enough to give us light and warmth, but far enough to keep us from burning up. Any closer, and you'd be just another marshmallow in the cosmic campfire, roasting in the unimaginable heat. The sun is truly hotter than your wildest dreams, so let's keep our distance and simply marvel at its power from afar. Now let's zoom in on the sun's surface and talk about its most intriguing features, sunspots. These dark patches are cooler regions, but still thousands of degrees hot. Some could swallow Earth whole. Sunspots are created by intense magnetic activity, twisting the sun's magnetic field lines and blocking heat. Their numbers wax and wane in an 11-year cycle, influencing space weather and even affecting radio signals on Earth. When the sun is extra spotty, it's also extra active, a warning for anyone relying on satellites or GPS. Those are cosmic blemishes you definitely don't want to pop. Occasionally, the sun shows off with spectacular fiery acrobatics, solar prominences. These gigantic arcs of plasma loop out from the surface, shaped by powerful magnetic fields. Solar prominences can last for days or weeks, sometimes erupting and sending bursts of charged particles toward Earth. Watching a solar prominence is like witnessing a cosmic ballet, graceful, powerful, and a little bit dangerous. The sun's version of a floor routine puts Olympic gymnasts to shame. Let's give a standing ovation to one of humanity's boldest explorers, the Parker Solar Probe. Launched in 2018, This spacecraft is the closest we've ever come to touching the sun, protected by a cutting-edge heat shield. No other probe has dared venture so close, skimming just a few million kilometers above the solar surface. Its mission? To unlock the sun's greatest secrets, from the origins of solar wind to the mysteries of the corona. The data it's collecting is rewriting what we know about our star. Parker isn't just a robot with a death wish. It's our eyes and ears on the front lines of solar science. The Parker Solar Probe has actually recorded what the solar wind sounds like. The solar wind is a stream of charged particles blasting out from the sun's atmosphere into space. Parker's instruments translate particle vibrations into sound waves, a haunting, otherworldly melody. These sounds help scientists understand how solar wind affects space weather and interacts with Earth's magnetic field. Out there, the sun is creating a wind of its own, one with a soundtrack that's been playing for billions of years. Let's talk about the sun's wilder side, supersolar storms that can shake our technological world. The most famous, the Carrington event of 1859, when a massive solar storm sparked auroras as far south as the Caribbean and fried telegraph lines. These storms are caused by bursts of solar wind and magnetic energy hurled into space during eruptions. When they collide with Earth's magnetic field, the results can disrupt satellites, GPS, and even power grids. Scientists watch the sun closely, hoping to predict these outbursts and protect our gadgets. When the sun gets moody, even our best technology has to take a step back. And there you have it, the sun in all its blazing, fascinating glory. From its overwhelming size to its mind-bending nuclear heart, the sun is more than just a bright spot in the sky. If you enjoyed this journey, don't forget to like, subscribe, and share your favorite sun fact in the comments below. See you next time, fellow stargazers, for more adventures into the wonders of the universe. Let me know if you need a further reduction or more creative tightening.